I feel it's particularly important that when you're working an application or a story problem, you're given an equation, that you should list the variables and write out for yourself what the variables represent. The problem that I'd like to look at now is found in Course Compass. It's found if you click on the Assignments button, and then I believe you're going to click on Small Projects. And I'm afraid I don't remember at that point. I believe you're going to click on Exponential Growth and Exponential Decay Models. There should be a folder there, and when you open that folder, you should find 3 problems. One involves the exponential decay of a car. That's the one you should print before you watch this portion of the CD. The next one is about an Olympic athlete having taken an antihistamine for a cold and looking at the decay rate of the medicine in their bloodstream. And the next one is the exponential growth rate of insects, like mosquitoes, in a population. I'm going to go over the first problem, the exponential decay rate having to do with cars. And they're all extremely similar. The equation that we're going to use is the value of a used car is equal to its original cost times its decay rate over some period of time, the decay rate raised to the t power. And the problem that I've got in front of me that you'll have to print out in Course Compass, it says, where V is the current value of the car in dollars, C is the original cost of the car in dollars, T is the number of years after the car is new, and then it doesn't say, D is the decay rate. It says a 1987 model, so you've got to remember it's a 1987 model, sold for $8,100. That was what its current value in 1990. That's 3 years after it was new. So T, 3 years after it was new, its value was $8,100. So I'm going to go here into this equation, and I'm going to put the $8,100 is equal to C times D to the third power, because it's in 1990 that we have this value, and this was a 1987 model, so it was 3 years old. I'm going to develop 2 equations because I'm given 2 pieces of data. My next piece of data says that it was worth $6,910 in 1991. So $6,910 in 1991. My exponent will now be 4, because 1991 is 4 years after 1997. You need to solve this system of equations. That's all it is. It's 2 equations with 2 unknowns. And I've basically asked you to find values for C and D. And then I've written there, give the original cost. Well, that is C, so that's kind of a redundant question. Actually, what I'm going to do is I'm going to take this a little bit further. Once I find the values for C and D, I'm going to write a model for this situation, and then I'm going to project the value of this car some number of years later. Now, here's how I would attack it. There's 2 ways to actually attack it. Because the variable C here is raised to the first power, I would take one of these 2 equations. I'm going to take the first and solve it for the letter C. And that's going to be equal to 8100 divided by D cubed, because I'm going to divide both sides by D cubed to get C alone. And then for C in the second equation, I'm going to substitute in 8100 divided by D cubed. Now I'm doing that so that I can have D in this equation. So I solved one equation for a letter, substituted the expression into the second equation. It's called the substitution method. When you solve a system of equations, you've done that a long time ago now. And I'm going to reduce this D cubed and this D to the 4th power, and what I'll have is just 8100D will be left. And so now I have to ask you to take your calculator and to divide both sides of this equation by 8100. And when you do, you'll have a value for the decay rate. And I've got 0.853. That basically means you're going to keep 85% of the value of the car every year from the previous year's value. So you drive it off the lot and it's worth 85%. 1 year later, it's worth 85% of that amount. A year later, 85% of that decaying amount. So that's my decay rate. To find my cost, my value for C, I personally would go into this equation that's rearranged, and I'd find C by taking 8100 and dividing it by 0.853 to the 3rd power. And when you do that, you should get a cost of $13,000, and I'm going to round this up to $47. It's actually $13,046.86 if you keep all your decimal places here. So we've got a value for C and for D in this equation. What that allows me to do is to write a model. A model for this situation says I could find the value of this car based on its original cost of $13,047, C, times its decay rate of 0.853 to the T power. Here's my model. So in all these problems, I'm going to be asking you for, if you will, this C value, this D value, put them into the original equation to establish a model. In this case, the value of a used car, T years from when it was new. And then finally, I might ask you, no, I don't on this sheet, as far as the decay of cars go. But I might ask you, what would the value of this car be in 1995? Well, it was new in 1987. So in 1995, it's now 8 years old. So what I would do is I would take this equation and I would substitute an 8 in for T there. And if you did that with your calculator, 0.853 caret to the 8 power, hit enter, multiply that by $13,047, and you would find that the value of that car would now be worth $3,657. I'm rounding it off to dollars just for space's sake. And I'm done with this problem. Again, I took the two pieces of data, put it into this equation. I took the value at 1990, the value in 1991. I solved this equation by substitution for the decay rate. I put that back into the original equation, or a version of the original equation, to find the cost. I wrote a model, cost and decay rate going into the original expression. Here's my model, and then I evaluated that model for 8 years later in 1991. Same problem, decay rate of car, but it's problem number 2 on the bottom of this sheet. And it says, complete this problem again with a 1999 model, so a little bit newer car, that sold for $11,615 in 2001. Well, it was 2 years old then. So its value was $11,615 when it was 2 years old. And, sentence goes on, it was $9,225 in 2003. So its value was $9,225 in the year 2003. Well, it's a 4-year-old car at that point. Again, it was a 1999 model, so now it's a 4-year-old car. I always prefer to solve the equation for this C value that's raised to the first power. I do that with the one that's got the smaller exponent. So C will be equal to 11,615 divided by d squared, because I've divided both sides by d squared. And now I'm going to plug in here that expression, 11,615 divided by d squared times d to the 4th, so that's going to be reduced in a minute. And d to the 4th over d to the 2nd is d to the 2nd, so I have 11,615 d to the 2nd. Unlike the last problem where I had just d, now I've got d to the 2nd equals 9,225. In order to solve for d, I'm going to divide both sides by the 11,615. And I'll have d squared equals, I've taken it a few decimal places, I've got 0.79423. Now I don't want d squared, I want d. So in order to get d, I have to take the square root of this side and the square root of that side. And so I find out that d is equal to 0.891. So the decay rate of this car is equal to 0.891. Now I have very little room here and I hate to get so congested. But I'm going to go and put that into this expression. I'm going to put the decay rate in here, square it, divide it into the 11,615, and I'll find the original cost of that car. And so if you took 11,615 for me and divided by 0.891 squared, you would get $14,624. That's the original cost of this car. And I'm going to go ahead and get rid of this and come on over here to show you the model. The model would then read that the value of this used car would be equal to its original cost of $14,624, so I'm putting that in for C, times the decay rate of 0.891, all of that, just the 0.891 raised to the T power. This is the model I'm looking for. I've stated what D is, I've stated what C is, and then if I said to you, find the value of this car in 2004, that would be 5 years later from when it was new. So you put a 5 in here for T, raise 0.891 to the 5th power, multiply it by 14,624 and get the value of that car. I'm hoping that this demonstration will help you with the fairly large assignment. I believe it's a 30-point assignment where I ask you to look at this Olympic casualty, because this Olympic athlete got disqualified from the games by taking an antihistamine or something for a cold that was prescribed by their doctor. And then look at also the problem involving exponential growth with insects. Do those problems by hand, scan them and send it to me in an email or fax it to me. And you're going to probably need to get that to me, I can't remember the date, but fairly quickly.